Okay guys, this is going to be the last of the instructional videos for this. I'll go over some problems, but for this chapter, this is kind of the end. We're going to talk about the last couple sections. The first part I want to talk about is actually the last section, which is the four universal forces. Okay, the first two were easy. Gravity. Gravity, as you know, is when you have two bodies, they will attract each other. Okay, so that's gravitational force. The second one is electromagnetic. And that's when you have two bodies, if they have opposite charges, and they will attract. Or if you have two bodies that have same charge, similar charge, they will repel each other. All right, so that's electromagnetic. Well, the other two kind of work together. One of them is called weak nuclear force. The other one is called strong nuclear force. And together, they keep the atomic nucleus together. All right, if you think about it, in the atomic nucleus, you have a whole bunch of protons and neutrons. And protons have positive charge and neutrons have no charge. So there's no negative charge, there's no electrons in there to balance any of this off. So these protons should want to fly away from each other, but these two forces work together to keep all of this happy and relatively happy in the nucleus. All right, so those are our four universal forces. Then we have to talk about momentum. Momentum has another formula. I know you guys are so excited. The formula here is this. So that's mass, and that's velocity. This is a Greek letter called, oh, I should erase that, called rho. It kind of looks like a lowercase p. I assure you it's not, but that stands for momentum. Okay, and it's just M is used for meters and mass. So and there's just too many things that we need M for. So they switched to a Greek letter. So momentum equals mass times velocity, and these problems are just as simple as the other ones that you did. So we'll say you want to know the momentum. And you have a mass of 1,000 kilograms and a velocity of 10 meters per second. Well, then you just, the mass is 1,000 kilograms times 10 meters per second. And so you get 10,000 kilograms times meters per second. Now, the one difference is here is that whereas with newtons, like kilograms times meter over second squared equals a newton, this you just leave it just as is. So that is that problem complete. Okay. The last part that we need to talk about is something called the law of conservation of momentum. And basically what this means is in a closed system, when you have some sort of collision, the momentum will be the same before and after. I'm going to tell you to go to the book. Actually, I have the book open right now, so I'll tell you exactly what page it's on. It is on page 376. Look at the train cars and look at the examples that they have there. It basically shows you all the different potential outcomes, but I'll just go through one quick one. We'll say you have something and it's moving it will say this is 10 kilograms, and it's going 5 meters per second in this direction. And it's going to run into this guy. It's also 10 kilograms, but it's staying still. So you have to figure out what the overall momentum. So if you look at the momentum over on this side, momentum equals mass times velocity. Well, momentum equals 10 times 5. So momentum equals 50 for that. Well, this one, the mass is 10, but the velocity is 0. So that means this one has no momentum. So overall, if you add these two together, you get a momentum of 50 kilogram times meter per second. All right, so this is the before situation. And then we have to figure out what the after situation is. Well, what would happen here is that this one would now be stopped. So this 10 kilograms, their masses haven't changed at all. These 10 kilograms, this one's now going to be stopped. And this one is going to be going off at 5 meters per second. So if you look at it, this one now has a momentum of 0. So this one has all the momentum because the overall situation has to equal 50. Okay. So this one must have all of the momentum. So 10 times 5 will give you 50. So that's the law of conservation of momentum. It basically means the before equals the after. Now this is in a perfect world. You guys know the things, and here I'll pretend I'm Sal Khan here, and the things that are called Newton's cradle, and they have the balls, and they swing back and forth. That's what the law of conservation of momentum is. It's if you pull one ball up and let it go, then this one will fly up here, and then it will come back here, and then one ball will fly up over here, and that's the law of conservation of momentum. Now, the reality is it's not a perfect system, and some will be lost, so it won't keep going on and on and on forever, but it'll go on for a little while. All right, so I hope you kind of understood that. If you have any questions, come see me.